So this is the code walkthrough video for the final project of Statistical Computing 2. First, we are gonna walk through the tasks that we have in this course project. We will use the FIFA dataset available on Kaggle for this project. And then we have 4 tasks. The first one is to build and populate necessary tables, including creating the database tables to store the data and populate it with data. And then we have to identify constraints as needed and document them in our README file. The second task involves conducting analysis on our dataset. We have to develop Python functions that run Spark to answer the following questions. Also, we have to do the core analysis via Spark. So the first one is list the X players who achieved average highest improvement across all the sets. The second is finding out the Y clubs that have largest number of players with contracts ending in 2021. The third one is listing the Z clubs with largest number of players in the dataset where Z larger or equal to 5. The fourth one is to finding out the most frequent nation position and team position in the dataset. The fifth one is to finding out the most popular nationality for the players in the dataset. So in the third task, we have to test our code and document it. We will use the unit test to cover all the functions that were developed above, including happy and sad pass scenarios. In the first task, we're gonna deploy our code to the cloud, running the code for all the 3 tasks above, including the DB creation process. So we are gonna introduce our GitHub repository. Under the data folder, we have the players' data from 2015 to 2020. And in our SRC folder, we have all the code for our task 1, task 2, and the main file, which is running the 2 tasks. And under the task folder, we have the test required in the second task. And also there is a README file serving as a conclusion for everything we've done. And now I'm gonna walk through the tasks separately. So first we're gonna walk through the codes we have for task 1, task 2, and then we will use the main file to execute the code in task 1 and task 2. First of all, we import all the required packages for Python, including FindSpark, PySpark, Encyclopedia2, and etc. So we first initialize the working directory for FindSpark, and then we set this working directory to the desired folder, and then we also saved our password towards the Postgres database in the secret.txt file. But first, we initialize Spark with our app name or master in this Spark driver host location. And now we are gonna read in our raw data. So the Spark parameter means the Spark session produced by the previous initiation. And we're gonna read in the FIFA data from 2015 to 2020 and union them into one data set. So these are all the raw data frames that we have in these 6 years. And then we union these 6 raw data sets into a union version in order to process the following analysis. So next, we're going to handle the missing values. First, we have this clean data function, which aims to drop the columns with more than 50% of NA values, and also dealing with the plus sign and minus sign in some columns. So the parameter is the union data, the raw data from 2015 to 2020, and the return should be a cleaned data in Spark. So this is how we check for missing values and delete columns with more than 50% of missing values. So we have this dropped NA50 data set, which is the dropped players union data with all these columns excluded. And now we're going to clean the plus sign and minus sign. We have all the columns here. And then we wrote a for loop to deal with to check the plus sign and minus sign and get rid of all the signs. So the return data will be the players PM data. But next step, we also have to impute the data. The impute data function is used to impute data value, impute NA values for numeric columns with mean. So the parameter here, we have players PM, which is the cleaned players data, and the return data should be the imputed data in Spark. So now we have all these columns that have null values somewhere. And this imputer players use the mean value to impute all the null column, all the numbers that have null values in these columns. So now we have this returned players imputed data. So after all of these cleaning process, the final step should be casting the types. So we cast the data into correct data types. Here we use players imputed, which is the imputed data, and then the return should be the final player data ready for analysis. So mostly we are handling the date of birth column, which is the date variable. So now the data should be ready for import. First, we write a function to delete the existing database, to delete the existing schema FIFA in the database. So we use the package cyclepg2 to connect to the database, the Postgres database. We have our username, password, and the port number. So we drop schema if the FIFA schema exists. So after running this, the existing database should be deleted. And next, we initialize the database. So the cyclepg2 connect is, again, the same thing in the previous step. And now we should have the new initialized database. Now we import the data into the SQL database using data import function. The data is the final data produced by cast type. So the username here is still Postgres, and password should be the password we stored in the secret txt file. And we're using this GDBC to connect Spark to the Postgres database. So now we should have our data imported. So when we run task 1 module in our main file, we should execute everything above with our processed data. So next, we're gonna talk about the codes we have in task 2. So we have, again, these required modules installed, and we are loading the players table from this SQL database in the previous step. So our return should be the player's data set ready for analysis. So we have 5 small tasks to do in this task 2. So we're gonna prepare our data set for that. Again, using the JDBC to connect our Spark to Postgres. And we should have the player's data. So in the first step task, we are listing the X players who achieved highest improvement across all skill sets. Our steps are obtaining the overall skill scores, which are calculated by aggregated scores of the 40 columns. And then the improvement should be the overall skill score in 2020 minus the one in 2015. So in the third step, we choose the players with top X improvement scores. Here we're taking 2 parameters. One is the players, the dataset players, and X, the number of players to show in our output. So the return should be a list of full names of players with top X improvements. So the codes are as follows. We have these skill columns, and then we minus these 2 values. And then we will have the top X number of improvements as a list of full names of players. So secondly, we have the largest club 2021 function to solve the second subtask. So we want to list the Y clubs that have largest number of players with contracts ending in 2021. So now we have 3 parameters to take in. These are the players, the dataset players, number of clubs to output, and the year of data to be used in integer. So there are 6 years in total. The return should be a list of the required club names. So first, we check for all these incorrect values to make sure that our input should be an integer value, positive, and the year should be integer and should be between 2015 and 2020. And secondly, we are finding the Y clubs that have largest number of players, the contracts ending in 2021. So we set this player contracts valid until 2021. And so we will have the number of clubs, Y club names for this task. So the third subtask involves in this largest club function. So we list the Z clubs with largest number of players in the dataset where Z is larger or equal to 5. So the parameter is still the dataset players, and we have a Z, the number of clubs to output, which should be larger or equal to 5. And we also have the year of data to be used in integer. The return value should be a list of the required club names. So first, we still check for the exceptions. Like the Z should be larger or equal to 5, and the input should be an integer value. The year should be integer, and year should be between 2015 to 2020. So next, our function will find out the Z values, like the Z clubs with largest number of players in the data set. So the returned value is the list that we're looking for. So here, if all the so if these conditions are satisfied, we print all teams have the same number of players. And if it's not satisfied if the length of this list is smaller than Z, we might have Z larger than club numbers, returning all the club's names we have here. So the fourth function is the popular nation team here. We want to get the most popular nation position and team position in the data set. So here we have the parameters, player, and year, the year of data that should be used in integer or for all the years. So the return value is set to be a dictionary with nation, the most popular nation position, and team's most popular team position. So first, again, we check for exceptions on year. That should be an integer and between 2015 to 2020. And then we are using this if else to select the most popular nation position and team position in the data set. So by all these executed steps, we will return a dictionary with nation and team. So there might be one exception, which should be a type error of dataset not in correct form. But that's just one possible exception condition. Mostly we will have this correct return. The fifth subtask is the popular nationality function. We want to get the most popular nationality for the players in the data set. So the two parameters are, again, players and year, our data set, and the year of data to be used from 2015 to 2020 in integer. So the return would be names of the most popular nationality for the players in the data set, and they should be in type of string. So first we check for exceptions, and then we use this function to find out the most popular nationality for the players in the data set. So by these steps, we will have a list of string which has name of popular nationality of the players in the data set in string. So these are the walkthroughs for task 1, task 2. Now we can execute the main file to see how these tasks give us outcomes. So after running this main file here, we have our data successfully imported. And here we're gonna check the data in our Postgres database. So here in our Postgres database, we have the FIFA schema, and under the FIFA schema, we have this players table. So if we select from this FIFA players, we can see that we successfully imported the data and all of the values are in the correct format. And now we're gonna view the reference of data in the DB visualizer. So in the FIFA schema, we are looking at the players table. We see that all the columns here are correct. And if we look at the reference here, we can see all of these column names and their types, integer, text, text date, well, mostly integer text and date. And we also identified some constraints here. So if we look at our README file, we're going to see the infrastructure of our table is provided here. And then the constraints are also available. And the first one, so FIFA ID is the primary key of this data set, and it is an integer. In DOB join are dates, and the contract valid until is a 4-digit integer for a year. So the overall potential attacking crossing to defending sliding tackle, haste to goalkeeping reflexes, and LS to RB are integer scores with range 0 to 100. They are mainly 2-digit scores. And firstly, the international reputation, weak foot, and skill moves are integer scores with range 1 to 5. The preferred foot, real face are binary characters with level left, right, and yes or no, respectively. The value EUR, weight EUR, and release clause EUR are integer representing money in euros. The height CM are 3-digit integers, and weight PG are 2 to 3-digit integers. These are the constraints we have. And for task 2, we also executed the output for task 2. The first one lists the X players who achieved highest improvement across all skill sets. We have these names: Adam Smith, Tom Davis, and Serge, and this name, and Muhammad. These 4 people who achieved highest improvement across all skill sets. And the Y clubs that have largest number of players with contracts ending in 2021 are Newcastle United, Dundalk, Houston Dynamo, Goya Grampus, and SL Benfica. So these are the 5 clubs that have largest number of players, contracts ending in 2021. And then the Z clubs with largest number of players in the data set where Z is larger or equal to 5 is Swansea City, Manchester United, FC Augsburg, Arsenal, Hannover 96, and UD Las Palmas. And the most popular nation position and team position in the data set are both SUP. The nation team are both SUP. And the 5th one get the most popular nationality for the players in the data set. We have this England as the most popular nationality for the players in the data set. So these are the task 1 and task 2. In task 3, we're testing our code and document it. So we're gonna go to the task folder here. And these are our tasks. So in our task 3, we are testing our code while document our code. So under the test folder, we have this test file to test out the happy and sad scenarios for the previous 2 tasks. First, we still import all the required modules, and we use this test load data to test the initial database. So the 3 assertions are used to test whether the table has been created, to test the column names and types, and whether the number of rows align with our record. And here the test top players happy is used to test the happy case of our top players. So the return variable should not be none for valid input. And we test answer for all possible x. And the sad case should be first, there might be an invalid input for x. So the type error should be reported. The inputs, like our inputs are non-string, non-integer, negative value, and 0. So we also check for the invalid input for players. And the type errors should be reported. Like the inputs are list, string, and integer. And also when x is larger than the number of clubs except output of all the clubs. So the second test is designed to test the largest club 2021. So the happy scenario is this year we first create a data frame for Spark session. And the happy scenario should be the return value is not none for valid input. And the answer matched for all possible y's. And the answers for all possible years are correct. And the sad scenario should be here invalid input for y. So the type error should be reported, including the incorrect inputs, non-string, non-integer, negative value, and 0. So these are all test cases associated to the incorrect y values. And also we test for invalid input for year. And also type errors are reported. The year should not be non-string, non-integer, negative value, and values not in 2015 to 2020 range. And also we check for invalid input for players. And the found inputs are list, string, and integer. So these are the sad cases. The third test is designed to test the largest club. The happy scenario is, again, the return value is not none for valid input. And the answers for all possible z is correct. And for all possible years are correct. So the sad scenario is when we create data frame like this, we test for invalid input for z, including the bound inputs of non-string, non-integer, negative value, and 0. An integer between 0 to 4 because z should be larger or equal to 5. And we also checked for invalid input for year, which is the same as the previous one. They should not be non-string, non-integer, negative value, and values not in 2015 to 2020 range. And the invalid input for players, again, should be list and integer. And z, we also checked for cases when z is larger than the number of clubs, expect output of all the clubs. Okay, so the first test is to test the popular nation. The happy scenario is, again, non-return for valid input is not none. And the test answer for all possible years are correct. So these are the test cases. In the sad scenario, when we create the data frame for Spark session, we're looking for invalid input for year, which are non-string, non-integer, negative value, values not in 2015 to 2020, and invalid input for players, which should not be list, string, and integer. And also we check for the most popular target value in player is none. So that's basically how we test this one. Here, it's also basically the same. When we're testing happy scenario, we check for none, and we check the values for year are correct. And then in the sad scenario, it's usually when the input, like when the years are not correct and the player values are not correct. So these are our 5 tests, excluding the one testing the data loading. So if we count this, we have 6 tests in total. So if we run this test, task 2, so this is our testing results. To see this clearly, we have the coverage report available. So here is our coverage report. Overall, we have a 79% of coverage, but for task 2, we have a 100% coverage, which is a great performance. And this overall coverage is still acceptable. So this is a detailed coverage in different modules. And also, the outcome of our test are included in our README file. And also our tests, our functions. And this is our task 3.